morning, students. Welcome back. Hey, guess what? We're on to a new chapter. We're on to chapter 9. The reason I chose to do this chapter, because we teachers had to kind of choose what to do, is because this one is kind of new. It's a little exciting, and it's very relevant to calculus. It's also very, I think, easy to learn in this format with a video and taking notes and doing the problems in the book. Chapter 5 was tough to do the way we did it. Chapter 9, though, I think will work a lot better for this format. I think you guys are going to enjoy it. Because this is an introductory lesson today, you will find that the notes this week are going to be a little longer. So make sure you print out the notes or you write the notes. And I think the assignment's going to be a little more straightforward. So a little more time with notes, a little less time with assignment is my prediction, but I've been known to be wrong. Anyways, what this new chapter is about is chapter 9, by the way. It is about what are called sequences and series. You have probably seen throughout your lifetime or your schooling this famous Greek symbol called a sigma. And you know, all these little fancy letters that go up here. And you're probably wondering, well, what in the world are all these things? Well, I'll tell you, that's what we're going to do in this chapter. So buckle up your seatbelts, grab a pencil, and start learning with me. Okay, here we go. First, a few little definitions. You need to know what a sequence is, and this is nothing really new. You've seen sequences before. A sequence is an ordered list of numbers. That's all it is. So for example, 2, 7, 12, 17, 22 is a sequence. Now, because I put ... and this one keeps on going forever, it is called an infinite sequence. On the other hand, in this example, I did 2, 7, 12, 17, 22, full stop. So this is called a finite sequence because it ends. That's all there is to it. Whenever you have a sequence, you can also come up with an equation or a formula for that sequence. Now, let's go ahead and do what we learned in Algebra 1, and let's just come up with an equation first of all. Over here, we're going to have in the domain the term number, and over here in the range, we're going to have the actual term. So you'll notice that if there were a zero term, theoretically, which there isn't, it would have been -3. This is just a linear equation, y equals mx plus b. And the equation would have been y equals 5x minus 3, or f of x equals 5x minus 3. So if I wanted to find the fifth term of the sequence, I could plug in 5 here, and I get 5 times 5 minus 3, which is 22, of course. So we can use function notation to actually describe a sequence. However, what we're going to be using in this chapter is sequence notation. It's a little bit different, but it's not hard. So what we're going to say is this. We're going to say, all right, this is the first term, a sub 1. That's how we describe the first term. This is the second term, a sub 2. This is the third term, a sub 3, and so on and so on and so on and so on and so on. And we could have a sub n being the nth term. So instead of writing our formula as an equation, we can write our formula this way. To find the nth term, you are going to do 5n minus 3. Notice it's almost the same, just slightly different. So then to find, for example, the fifth term, we'd say a sub 5 equals 5 times 5 minus 3. In other words, a sub 5 is 22. And as you can see, a sub 5 is in fact 22. A sub 5, S-U-B as a subscript. A sub 5 is the way that is pronounced. Okay. So there's some basic notation for you. Let's do a few little examples. And in this first example, what we're being asked to do is to find the first 5 terms of the sequence. All right? And it tells us that a sub n equals 5n minus 1. That implies that a sub 1 is going to equal 5 times 1 minus 1. In other words, 4. A sub 2 is going to be 5 times 2 minus 1. In other words, 9. A sub 3 is going to equal 5 times 3 minus 1. In other words, 14. So on, so on, so on, and so on. I'm not going to bore you with it. You're probably going to figure out what the next ones are. If it's 4, then 9. It seems that it's increasing by 5 each time. So my fourth term will be 19, and my fifth term will have been 24. We could repeat this process for all of them. Yeah, but you're in pre-calculus, you probably could figure that out. Let's do one that's a little bit harder. Let's go ahead and find the first 5 terms of this guy. Now this is evil looking. It's a sub n equals 2 plus negative 1 in parentheses to the n power divided by n. Let's try that. All right, so a sub 1 is going to equal 2 plus negative 1 to the first power divided by 1. All right, that is going to be 2 minus 1 over 1. So my first term is 1. So a sub 1 equals 1. Let's find the second term. The second term of the sequence is 2 plus negative 1 squared divided by 2. All right, now notice what happens here. When we have the negative 1 to the second power, it becomes a positive 1. So now all of a sudden this is plus 1 over 2. And therefore my next term is 3 over 2, or 1.5. The third term, 2 plus negative 1 to the third over 3. Now I have negative 1 to the third. Notice what happens now. Negative 1 times negative 1 times negative 1 is negative 1. So now it's 2 minus 1 over 3, which is now going to be 1/3. Notice that this sequence starts at 1, then it goes up to 1.5, or 3 over 2, then it goes down to 1/3. So this sequence is kind of going up and down and all over the place. I know it says to find the first 5 terms. I can't fit them, but you can probably figure it out. In fact, I'll let you know what the other terms were. The fourth term, if you were to do this, and you could try it, is 3/4. And the fifth term, if you try it, you should get 1/5 by completing this process. This is something I really want you guys to notice. This negative 1 to the n. As we change the n, it goes from a negative 1 to a positive 1, back to a negative 1, back to a positive 1. It's going to flip the sign back and forth. That's going to come in handy a little bit later, so pay attention to that. Okay, let's do it backwards. This one says write an expression for the nth term. Okay, so it wants you to write basically an equation for it. So let's see. I would kind of treat it this way. Treat it like a function. So your first term is 1, your second term is 5, your third term is 9, your fourth term is 13. I'm going up by 4. So theoretically, my 0 term, if there were one, would have been negative 3. So I could say that as an equation, this is f of n equals 4n minus 3. So in sequence notation, that's a sub n equals 4n minus 3. And you can always check to see if you're right by plugging in a number. Like saying, all right, let's try to find, I don't know, the third term. So let's plug in a 3 there. And I get 12 minus 3, which is 9. Is the third term 9? Yeah, so I did it right. Let's do one that's a little bit harder here. This is not linear. It's not going up by a constant amount at all. Therefore, it's a little bit tougher to do. But I'm hoping that you will notice a few things. Let's see. I'll go over here in the margin. Look at this sequence right here. 1, 4, 9, 16, 25. Do you notice anything about these numbers in relationship to these? Good. These are the perfect squares. These numbers are simply one more than the perfect squares. So let's see. Our formula is going to be just take these and square it. So let's see. Let's try n squared plus 1. So watch what happens now. So for example, the third term here is going to be a sub 3 equals 3 squared plus 1, which is in fact 10. But there's a little problem with my formula. You'll notice that it goes positive, negative, positive, negative, positive. So somehow I need to flip this thing back and forth. And that is where that friend of yours comes in handy. So let's go ahead and try that now. Let's multiply it times negative 1 to the n. So let's see what would happen if I did that here. If I plugged in the third term, negative 1 to the third would be negative. Oh, I want my third term to be positive. So I'm going to do this. I'm going to make this n plus 1. Now watch. Plugging in a 3 here. Let's do the whole thing. Plugging in a 3. I'm going to get 3 squared plus 1. That gives me the 10. Now I want it to be positive, and negative 1 to the power of 3 plus 1. That's the fourth power, and negative 1 to the fourth is positive 1. So I'm going to get a positive 10 there. Now watch what happens when I try to find the fourth term. The fourth term is going to be 4 squared plus 1. That's the 17. But I want the 17 to be negative, and check it out. Negative 1 to the 4 plus 1. 4 plus 1 is 5. Negative 1 to the fifth is negative 1. So negative 1 times 17 will give you negative 17. So this is the tool you're going to have to use to flip the signs around. Positive, negative, positive, negative, positive, negative. This is the machine that will cause it to go positive, negative, positive, negative, positive, negative, positive, negative. That is a good friend of yours. All right, I'm going to pause this first video right here, and I'm probably going to have quite a few videos this week. Let me keep it in a short little bits. Okay, go to video 2 once you're done with this one. See you soon.